Okay, so in the 10.5 lesson, we learned about a whole bunch of different angles. And basically, the way I characterized those angles were based on where the vertex of the angle was. And we all know from before 10.5 about central angles. So let's just start there. You guys don't have to write this down. I'm just recapping 10.5. So we know a central angle is an angle whose vertex is at the center of the circle. And what do we know about the central angle and the arc that it intercepts? Central angle and the arc are what? The same degree measure. So if this central angle is 60 degrees, then the arc is 60 degrees. If the arc is 60 degrees, then the central angle is 60 degrees. So for central angle, we know angle is equal to the arc. All right. Then, like I said, we categorized everything based on the location of its vertex. So we first spoke about what happens when the vertex is on the rim of the circle. And I called those on angles. And an on angle, one of the on angles we talked about was an inscribed angle, something like this. So here's our angle. We're working with the arc that it intercepts. So it's this arc right here. What is the relationship between an angle whose vertex is on the circle and its intercepted arc? PJ? You got it. So for this one, for the on angle, it is the angle is equal to the arc divided by 2. All right, then we had an angle that was inside but not the center. So an angle inside but not at the center looks like a chord angle, two chords intersecting. So let's say I wanted to find angle 1. Who remembers what the formula for this one was? Only PJ. Did only PJ watch the video? Who else? Oh, it's not good, guys. All right, so if we're trying to find angle 1, let's say this is arc AB and this is arc CD. What you do is you're going to take the first arc, so the arc of the angle that you're looking for. So we're going to say arc AB. And then you're going to look at its vertical angle. So this is angle 2. So then you're going to add the arc of its vertical angle, arc CD. So this arc plus the arc of its vertical angle, and then you divide it by 2. So it's arc plus arc divided by 2. All right, there was one more category, and we said if the vertex of the angle is outside the circle, that could look something like a secant angle, something like that. So if we're trying to find this angle, the formula for this is going to be the big arc that's intercepted. So we're going to say big arc minus the small arc that's intercepted divided by 2. And those were the different formulas that we were working with last time. All right, so now let's go back to our do now. We're going to use all of these formulas to help us answer all of these questions. So the first thing we want to do is go through our given information. The only thing we're told is that it's circle O. And even though this doesn't seem like a big bit of information, it actually helps us tremendously, because by identifying the center of the circle, knowing that O is the center, I can then identify diameters. And why is it helpful to identify a diameter? What does a diameter do to a circle? What's a diameter do to a circle? It splits it in half. So a diameter splits it 180 degrees on top, 180 degrees on the bottom. So what we want to do is we want to find arc AB. And if you notice here, I have, oh, I'm missing some points. Where are all my letters? All right, let's give these points. Let's call this D, F, H, I. So if you notice, I have arc BD, I have arc DF, I have arc DH, I have arc HI, and I have arc AI. So I'm missing arc AB. Any ideas on how I can find arc AB? Sarah? Good. So ID is a chord that goes through the center of the circle. So ID is a diameter, and a diameter splits a circle in half. So from I to D is 180 degrees. So what Sarah's telling us to do is add the other two arcs, 54 plus 62, and we get 116, and then take that 116 and subtract it from 180. And we end up getting 64 degrees. We know this is 64 degrees. All right, now what we want to do is start finding some angle measurements. The first angle we want to find is angle 1. When you're dealing with these complicated angles, what you want to do, or what I do, I should say, is I highlight the full angle and I extend it as much as I can. So we know this is angle 1, but what I want to do is extend angle 1, the two sides of the angle, as much as I possibly can. So what does that mean? Here's the vertex. It extends past A. Here's the vertex, and I'll extend it past B. I just follow the full angle all the way through. And then you're going to ask yourself, this angle that I'm dealing with, is it a central angle? Is it an inside angle but not at the center? Is it an on angle on the rim of the circle, or is it an outside angle? It's vertex outside the circle. So you tell me, angle 1, inside, outside, or on? Yeah. It's outside. It's outside. So now we're going to use the outside formula. What does the outside formula tell us to do? It says big arc minus small arc divided by 2. So now, if you look at the angle like a Pac-Man mouth, you're going to see the arcs that the Pac-Man mouth is eating. So for sure, angle 1 is eating the arc of the Pac-Man mouth, right? It's eating arc 22. But what's the other arc that it's also eating? The 64. So those are the two arcs. You always put the bigger arc first because we're subtracting and we don't want negatives. So we're going to say 64 minus 22 divided by 2. Well, 64 minus 22 is 42. 42 divided by 2 is 21 degrees. So angle 1 is 21 degrees. All right, now we're going to look at angle 2. So let's go to angle 2 and highlight. Is angle 2 a central angle? No, because its vertex is not at the center. So I cannot say angle 2 is 62 degrees. It is not 62 degrees. All right, so then we ask ourselves, since it's not a central angle, is it inside, outside, or on? Inside, yeah, it's an inside angle. So that means we're going to do arc 1 plus arc 2 divided by 2. So you look at angle 2 and you look at the arc that angle 2 intercepts. When I say angle 2 intercepts it, like I'm saying angle 2 is the Pac-Man. Which arc is the Pac-Man eating? It is eating the 62 degree. But then I need another arc. Where do I get the other arc from? PJ? You got it. You look at angle two's vertical angle, and then you try to find the arc for the vertical angle. Now, angle two's vertical angle is going from arc I, from point I all the way, or, oh, I don't know what letter that was supposed to be. I think that was supposed to be a D, all the way to F. So the second arc we're dealing with is not 114 and not 22. It's 114 plus 22, which is 136. So now we're going to add 62 plus 136 divided by 2. So we have 198, and now we're going to do 198 divided by 2, and we get 99. All right, can I erase all my highlighting here? Anybody still copying? So we got angle 2 is 99. All right, let's keep going. Now we're going on to angle 3. Once again, angle 3 is an inside angle. So here's our inside angle. Our arc is 44, but what's the other arc? It's not 64, it's not 54. Isn't it the whole AD? 64 plus 54 for its vertical angles arc? So we do 64 plus 54 is 118 for arc AD. And then we're going to do arc plus arc divided by 2 again. So we're doing 44 plus, what did I just say that was? 118 divided by 2. Anybody confused with how I'm getting these numbers, PJ? Oh, because you're seeing the straight angle? Yeah, you could absolutely do that. PJ saying, right here we have, oh, other way. Right here we have a straight angle. So that's another way to do that. I like that. Should work out the same. Did it work out the same? I don't know. All right, let's see. 118 plus 44, 162. 162 divided by 2 is, yep, 81. We're good. All right, I want you guys to do angles 4 and 5 by yourself. Do angles 4 and 5 by yourself, and then we'll go over them. All right, let's go over this. So let's do angle 4 first. So I go ahead and I trace angle 4. Do we all agree that's an on angle? So if it's an on angle, the formula tells us to do the arc that it intercepts, which is 44, divided by 2, which is going to be 22 degrees. How many people got that? Great. All right, so now we want to go on to angle 5. And I'm going to go ahead and trace angle 5. What kind of angle is angle 5? It's a central angle. Because its vertex is the center of the circle, that means the arc and the angle are the same. So angle 5 is 54 degrees. All right, so now on to section 10.6. So number 1, it says given circle O, and we want to find angle A. They're not telling us any arc measurements or angle measurements. They're really not giving us any of that. But because we know that that the circle's center is O, do we all agree that this segment right here is a diameter? And that a diameter splits a circle in half. So this arc right here is 180. Okay, so now if we're looking at angle A, angle A is an on angle. So what does that mean? The on angle is the arc divided by 2. Well, what arc are we eating? Isn't this eating the full diameter? So it's eating the semicircle. So if the on angle is eating the diameter, its arc is a semicircle, that means it's going to be 180 divided by 2, which is 90. And this is an inscribed angle. All right, that's not a coincidence. This is actually a theorem. We're not doing any proofs with this, but this is just so we could apply it to algebra problems. An angle inscribed in a semicircle is a right angle. All right, so given circle A, so we know the center of the circle is A, arc BC is 60, segment BC is 12 units long. We want to find the perimeter of this triangle. All right, what do I need us to recognize? I need us to recognize that, see how angle C is an on angle? And you see how it's eating the diameter, BD? Well, what did we just learn? An on angle that eats the diameter has to be what kind of angle? A right angle. So this is a 90-degree angle. We're going to do even more work here. So we know this is a right angle. Now, I see arc BC is 60 degrees. That's the only thing they told us. Well, I'm going to look for an angle that eats the arc BC. Does anybody know which angle intercepts arc BC? Good. Angle D. And I'm going to ask you, angle D, is it inside angle, outside angle, or an on angle? It's an on angle. So angle D will equal the arc divided by 2. And the arc that it's eating is 60 degrees. So it's 60 degrees divided by 2. So angle D is 30 degrees. So if I have an angle that's 30 degrees and 90 degrees, what's the last angle have to be? 60. This is a 30, 60, 90 triangle. So I'm going to go ahead. I'm going to redraw this triangle. So I could do some work on it. So they told us BC is 12 units long, angle D is 30, angle B is 60. Well, we need to remember that in a 30, 60, 90 triangle, across from the 30 is x, across from the 60 is x root 3, and across from the 90 is 2x. So at this point, what do? We set the variable equal to the number. So x is equal to 12, nothing to solve there. Now that we know x is equal to 12, BD is 2x, which is 24. What's CD going to be? Good, 12 root 3. So the perimeter is going to be 12 plus 24 plus 12 root 3, which is going to be 36 plus 12 root 3. All right, next theorem. The sum of the measure of a tangent-tangent angle and its minor arc is 180 degrees. All right, once again, what is a tangent-tangent angle? A tangent-tangent angle is an angle that's outside from a single point, and then from that vertex, the two sides of the angle are tangent to the circle in only one place. Well, that's what it means to be tangent to circle, meaning it only touches in one place. That's what a tangent-tangent angle looks like. So it's an outside angle, and the two sides of the angle only touch, each side only touches the circle in exactly one spot. So this theorem's telling us that the tangent-tangent angle and the minor arc that it intercepts add up to 180 together. So for example, if this arc is 100, that means the angle is 80. That's what that means. So here, if arc TS is 130, angle P has to be 50. This only works for tangent-tangent angles. So let's say I gave you this. Would I be able to say this is 100? No, I wouldn't be able to say that's 100 because the other side is not a tangent side. Only works for a tangent-tangent angle. Both sides could only touch the circle in one spot. All right, let's look at number 4. So it says PA and PB are tangents, and we want to find angle P. Well, I'm telling you that angle P is represented by 6x, and the minor arc that it intercepts is 15x plus 33. Any ideas on an equation that will help us solve this? You got it. 6x plus 15x plus 33 equals 180. The tangent-tangent angle and its minor arc add up to 180. So we're going to have 6x plus 15x is a 21x plus 33 equals 180. Anybody want to do this for us? Solve for x. All right. Do it. Then we divide by 21. We get x is equal to 7. So now we want to find angle P. Well, angle P is 6x. So angle P will be 42 degrees. All right, number 5. So here it's telling us arc AB is 145 degrees, angle Y is 48 degrees. I want to find angle Z. So I'm going to look at angle Z. Here's our circle. Do we all agree angle Z is an outside angle? Wait, even more than that, do we agree that angle Z is a tangent-tangent angle? Meaning this angle and this arc add up to 180. The problem is, do I have this arc? No. I know a full circle is 180 degrees, and I know arc AB, and not 100 degrees, 360 degrees, and I know arc AB is 145. But do I have the other arcs to be able to figure this one out? No. So there's no direct way in finding this right off the bat. So we're going to have to sort of work outside the box a little bit. All right, well, we said we know a full circle is 360 degrees. I already have arc AB. Let's look to see if we can find arc BC. Right, what kind of angle is angle Y? It's an outside, and more than just an outside, what kind of special angle is it? Tangent angle. So that means arc angle Y and arc BC add up to 180 together. So I can now find arc BC. So we're going to say arc BC is going to be 180 minus 48. So we're at 132 degrees. So now that I have arc AB is 145 and arc BC is 132, can I now find arc AC? Absolutely. So we're going to go ahead and add the 145 plus 132. We will get 277. Then we will take that 277 and subtract it from 360. We will get 83 degrees. All right, now you all tell me, how does this help us? Now that we know that arc AC is 83 degrees, how will this help us? Good, because angle Z is a tangent-tangent angle. The tangent-tangent angle and its minor arc add up to 180. So we are going to do 180 minus 83 and get 97 degrees. All right, let's keep going. All right, looking at number 6, we want to find angle A, angle B, and angle C. Can I say angle A is 130 degrees? How many people say yes? How many people say no? Why no? Sarah, why no? Good. It's not a tangent-tangent angle, so can't say that. All right, let's look at angle B. Can I say angle B is 70 degrees? How many people say yes? How many people say no? Good, you all win. Because it's a tangent-tangent angle, we could say angle B is 77 degrees. All right, then angle C, can I say angle C is 140 degrees? How many people say yes? No, this is a no. Why? Because this one touches in one spot, but if you take the other side of angle C and you extend it, won't it end up touching it again? So that other side is not a tangent side. So this is not a tangent-tangent angle. So therefore, I cannot say it's 140 degrees. All right, so what can we do? Well, go back to angle A. Do we agree angle A is an outside angle? We could use the outside angle formula. So angle A is going to equal big arc minus small arc divided by 2. So let's trace this angle. So if we're looking at the two arcs that it intercepts, I'll highlight them in purple. The first arc is 50 degrees, but the second arc, do we all agree it's 110 all the way past 40, that whole arc? So this is 150 degrees for its bigger arc. So angle A is going to be 150 degrees minus 50 degrees divided by 2. So angle A will be 50 degrees. All right. Someone tell me, there's two different ways now to find angle C. Somebody tell me one way to find angle C. There's two different ways. PJ, give me one way. Good. Do you guys see that ABC is a triangle? Doesn't all the angles in a triangle have to add up to 180? We have 2 out of the 3 angles, so we could add 50 and 70, subtract from 180, and get our last angle. That's the quickest way to do this. What's another way we could have done this? Abby? Good. Notice that angle C is an outside angle and say big arc minus small arc. I don't care which way you do it as long as we get it. So I'm going to add the two angles. 50 plus 70 is 120. And then 180 minus 120 is 60 degrees. So angle A was 50 degrees and angle C was 60 degrees. All right, so now we're going to talk about inscribed and circumscribed polygons. Now, this is going to show up in a section past 10.6. So we have to really understand what this means, especially inscribed polygons. All right, a polygon is inscribed in a circle if all of its vertices lie on the circle. So if we notice, I have circle O and I have triangle ABC. All of its main vertices, all of its corners are A, B, and C are actually on the rim of the circle. That's what it means to be inscribed. If I were just to draw, you guys don't have to draw this, but if I were just to draw this, this is not a triangle inscribed in a circle. That's just a triangle inside of a circle. Inscribed means all its vertices are on the rim. Right? A polygon is circumscribed about if each of its sides is tangent to the circle. So for example, if I wanted to draw a triangle circumscribed around about a circle, it would look like this, where each of the sides of the triangle are tangent to the circle. All right, theorem. We're not going to do any proofs, but we will use this in algebra problems. If a quadrilateral is inscribed in a circle, its opposite angles are sup. So what does this mean? If I have quadrilateral ABCD is inscribed in circle O, angle A plus angle C equals 180, and angle, there's a D right here, angle B plus angle D equals 180. All right, let's do a problem. So here I have arc BCD. So they're talking about our major arc here, BCD, because they use 3 letters, is 208 degrees. We want to find angle A. So I'm going to go ahead and I'm going to trace angle A. Do we all agree angle A is an on angle? So for angle A, our formula is going to be angle A is the arc divided by 2. The arc it intercepts is arc BCD. So we're going to say 208 divided by 2, which is 104. All right, now we want to find angle C and angle D. Well, isn't this a quadrilateral? Is this quadrilateral inscribed in the circle? Absolutely. That means the opposite angles are supplements. So that means angle C is going to be 180 minus 104, which is 76 degrees. And angle D is going to be 180 minus 67, which is 113 degrees. All right, number 8. Given angle Q is 100 minus 2x and angle A is x squared, we want to find angle Q. Well, is this a quadrilateral inscribed in a circle? So what do we know about the opposite angles? They're not congruent, they're what? Supplements. So that means x squared plus 100 minus 2x is equal to 180 degrees. What am I most likely going to have to do here? Good, so we could do what? What's the word I'm looking for? The algebra word. Starts with an F. Factor. We're going to have to, most likely we're going to have to factor. How do I know this? Because of the x squared. So I see an x squared, I'm going to go factoring. And so following in route with what PJ was saying, in order to factor, we need to set it equal to 0. I'm also going to put it in descending order. So it's an x squared minus 2x plus 100 equals 180. So I first put it in the right order, and now I will subtract that 180. So we have x squared minus 2x minus 80 equals 0. All right, who has factors of 80? So two numbers that multiply, to a negative 80, but add to a negative 2. Good, a negative 10 and a positive 8. So now we solve, and we end up getting x equals 10 and x equals negative 8. Guys, you are absolutely allowed to have a negative x. What you're not allowed to have is a negative angle when you plug in. So if I go and I plug in 10 for angle Q, I get 100 minus 20, which is 80. Is that an acceptable answer? Absolutely. So one answer is 80. I still have to check the other one. The other answer is going to be 100 minus 2 times a negative 8. Well, what's a negative 2 times a negative 8? Isn't that a positive 16? So this is a positive 116. That is also an acceptable answer. So our answers are either 80 or 116, but we need both answers written down. All right, and the very last part of today's lesson. If a parallelogram is inscribed in a circle, it must be a rectangle. All right, real quick, let me explain to you why. Do we agree that a parallelogram is a quadrilateral, right? Always. So we know if a quadrilateral is inscribed in a circle, the opposite angles are supplements. Didn't we just use then apply that? Right, but if it's a parallelogram, by definition or by the theorems of a parallelogram, aren't the opposite angles congruent? So if the angles are congruent and they're supplements, what kind of angles do they have to be? Congruent and sup must be how many degrees? 90. So if I have a quadrilateral with all 90-degree angles, doesn't that mean it must be a rectangle? Right, so that's why they're saying if you have not just any quadrilateral, a parallelogram inscribed in a circle, it's going to be a rectangle. Right, so what does this do for us here? So they're saying given circle O, so O is the center of our circle, the radius of this circle is 6. Can somebody identify 2 radii for me right now in the diagram? Abby. You got it. OH is 6, OF is 6. Find the perimeter of EFGH. Okay, well, because EFGH is a parallelogram. Is this a parallelogram inscribed in a circle? Yes, which means all these angles are right angles since it's a rectangle. Parallelogram inscribed in a circle is a rectangle, so that means I get all right angles. Does anybody know where I'm going with this? Gabby?
Well, because they're right angles, I had to get 60 and 90, the other angle is 30.
You got it. I'm going to work with this right triangle. That's a 30, 60, 90 triangle. So I'm going to redraw this. So we have HGF. HF is 12 because a 6 and a 6 is a 12. So opposite the 30 is x. Opposite the 60 is x root 3. Opposite the 90 is 2x. We're going to solve for x. So 2x equals 12. So x will equal 6. So GF is 6 and HG is 6 root 3. So I'm going to go back to my quadrilateral. GF is 6. HG is 6 root 3. I was asked to find the perimeter. What should I do? I only have 2 sides. PJ? Why? Good, because in a rectangle, aren't opposite sides congruent? So if the top is 6 root 3, the bottom 6 root 3. If the right is 6, then the left is also 6. So our perimeter is going to be 12 plus 12 root 3. Yep, and we are done for today. Don't worry about the homework.